Picture the outer edges of our solar system, a cold, dark expanse where the sun's rays barely reach and the stars seem frozen in an eternal night. It's here, in this desolate frontier, that something strange began to stir the imaginations of astronomers. In 2016, two scientists, Mike Brown and Konstantin Batygin, stumbled upon a cosmic anomaly that would ignite a global hunt. They weren't searching for a new planet, they were simply trying to make sense of a peculiar pattern among a handful of icy objects drifting far beyond Neptune. These weren't comets or asteroids, but extreme trans-Neptunian objects, etnos, frozen relics of the solar system's ancient past, orbiting in the distant Kuiper Belt and beyond. What caught their attention was astonishing. These ETNOS weren't scattered chaotically, as you'd expect in the wilds of the outer solar system. Instead, their orbits were eerily aligned, tilted in a similar direction, and pointing toward the same region of space. It was as if an invisible hand was guiding them, herding them into a clustered pattern that defied statistical probability. In a stable solar system, objects this far out should follow random, haphazard paths, shaped by billions of years of gravitational tugs and cosmic chaos. But this was different. This was a clue. Imagine stumbling across a set of footprints in an untouched desert, all leading in the same direction. You'd wonder what's guiding them. That's exactly what Brown and Batygin felt as they pored over the data, their curiosity sparked by a pattern that seemed to whisper of something massive, something unseen. Brown and Batygin, both seasoned astronomers at Caltech, crunched the numbers with a fervor that only comes from chasing a cosmic mystery. The math pointed to one conclusion: something massive was out there, exerting a gravitational pull strong enough to sculpt the orbits of these distant objects. It wasn't Neptune, whose influence fades far closer to the sun. It wasn't Pluto, a mere dwarf planet with negligible gravitational clout. No, this was something far bigger, a hidden world, perhaps 5 to 10 times the mass of Earth, lurking in the shadows at 400 to 800 times Earth's distance from the sun. For perspective, Neptune orbits about 30 times farther from the sun than we do. This mystery object, if it existed, would be a true giant, dwelling in a realm so remote that sunlight takes hours to reach it, painting it in faint, ghostly hues. They called it Planet 9, not because it would restore the count after Pluto's demotion in 2006, a decision ironically driven by Mike Brown, earning him the nickname Pluto Killer, but because it was the only explanation that fit the data. Their 2016 paper, published in the Astrophysical Journal, laid out a compelling case. A massive planet could explain not only the clustering of etno-orbits, but also the peculiar tilts of some smaller objects in the Kuiper Belt. Yet there was one glaring problem. No one had seen this planet. It was invisible, a ghost in the data, and so began a worldwide hunt that would captivate scientists, spark debates, and draw in amateur stargazers, all united by a single question: could we be on the verge of discovering a new world? The discovery of this orbital anomaly sent shockwaves through the astronomical community, like a stone dropped into a still pond. Telescopes around the globe turned their gaze to the distant sky, scouring the predicted regions where Planet 9 might lurk. Amateur astronomers joined the effort, sifting through online databases and citizen science platforms like Backyard Worlds, Planet 9, their screens glowing late into the night as they hunted for a faint speck that could change history. The search wasn't just about spotting a new planet, it was about confirming a theory that could rewrite our understanding of the solar system. It was about proving administration that the cosmos still held secrets, waiting to be uncovered by those bold enough to look. As more ETNOs were discovered, the evidence seemed to grow stronger. Some of these objects shared the same strange orbital alignment, and a few even followed retrograde orbits, moving opposite to the solar system's usual flow. An act of cosmic rebellion that only deepened the intrigue. Each new find bolstered the Planet 9 hypothesis, as the math continued to point to a massive, distant object pulling the strings. But there was a catch. Despite years of searching, no one had directly observed Planet 9. Telescopes like Pan-STARRS, Subaru, and the Dark Energy Survey scanned vast swaths of the sky, while researchers combed through archived data from missions like WISE and IRAS. The task was daunting. Imagine trying to spot a single firefly in a midnight forest, knowing it might not even be there. Yet the planet remained elusive, a shadow that refused to step into the light. The absence of direct evidence sparked skepticism, as it always does in science. Some scientists, like Samantha Lawler and Jean-Marc Petit, argued that the clustering might be a statistical fluke, a mirage born of observational bias. After all, the sample size was small, only a handful of ETNOS, and most were discovered by surveys that focused on specific sky regions at certain times of year. It was like pointing a flashlight into a forest and concluding all the trees grow in one direction. To test the theory, researchers ran sophisticated simulations modeling the solar system with a hypothetical planet 9. In many cases, the simulations recreated the observed clustering, lending credence to the idea. But alternative explanations emerged, each vying for attention. Perhaps a massive disk of small objects, not a single planet, was responsible for the gravitational effects, acting like a cosmic soup tugging on the ETNOS. Or maybe passing stars in the solar system's early history had scrambled the orbits, leaving behind a chaotic legacy. A fringe group even suggested that gravity itself might behave differently at such vast distances, though this idea gained little traction among mainstream astronomers. The debate intensified, splitting the community into believers and skeptics. Planet 9 remained the cleanest explanation, but the lack of a sighting fueled doubt. Every new survey that turned up empty narrowed the search area, yet the clustering remained unexplained. The theory was neither proven nor disproven, trapped in a scientific limbo where hope and frustration coexisted. But then, in early 2025, a breakthrough shifted the narrative, not from a new observation, but from a fresh look at decades-old data, pulling the mystery back into the spotlight. After years of fruitless searches, hope emerged from an unexpected source. The dusty digital archives of the Infrared Astronomical Satellite, IRAS, from the 1980s, and Japan's AKARI satellite from the 2000s. A team of astronomers, driven by a mix of curiosity and desperation, pored over these datasets and spotted something intriguing: a faint, slow-moving object detected in both surveys, roughly 20 years apart. Its motion was too slow for a star or galaxy, and its infrared signature suggested a cold, distant body, possibly a planet hundreds of astronomical units away. The discovery sent ripples through the scientific community, like a faint signal from a distant shore. Could this be Planet 9 finally revealing itself after years of hiding? The object's faint glow and sluggish drift matched what astronomers expected from a distant, massive planet reflecting minimal sunlight. At 400 to 800 astronomical units, Planet 9 would be so far that the sun's light would be a mere glimmer, rendering it nearly invisible to optical telescopes. But in the infrared, where cold objects emit faint heat, it might just be detectable. News outlets pounced on the find, with headlines proclaiming Planet 9 found, and social media buzzing with excitement. For a moment, it felt like the mystery was on the verge of being solved. Astronomers held their breath, hoping this was the breakthrough they'd been chasing for nearly a decade. But science, as always, demanded scrutiny. A closer analysis revealed a problem. The object's orbit was all wrong. Planet 9 was predicted to follow an elongated but relatively flat orbit, tilted 15 to 30 degrees from the solar system's plane. This object, however, was tilted over 120 degrees, practically upside down, and moving in a retrograde direction, opposite to the solar system's flow. Mike Brown himself, one of the original architects of the Planet 9 hypothesis, stepped in to temper the excitement. "It's definitely not our Planet 9, he said in a 2025 interview with Science magazine. "It might be a large trans-Neptunian object, perhaps a dwarf planet, but it didn't explain the ETNO clustering that sparked the theory in the first place." Instead of resolving the mystery, this discovery deepened it, like a plot twist in a cosmic thriller. It suggested that the outer solar system might be far stranger than anyone had imagined, potentially teeming with unknown objects that defy our models. What if Planet 9 wasn't alone? What if the Kuiper Belt and beyond harbored a menagerie of rogue worlds, each contributing to the gravitational chaos? The find didn't debunk Planet 9, but it forced astronomers to confront a new reality. The outer solar system was a wilderness of surprises, and we'd only scratched the surface. If old data from outdated satellites could reveal such anomalies, what else might be lurking in the cosmic shadows? The discovery rekindled enthusiasm, not just for Planet 9, but for the broader quest to map the uncharted reaches of our solar system. It was a reminder that sometimes the most profound discoveries come from looking backwards, sifting through the relics of past observations to find clues to the future. Just when the Planet 9 saga seemed to settle into a predictable rhythm, a new discovery threw everything into disarray. In 2024, astronomers announced the detection of a distant object dubbed 2017 OF 2001, a dwarf planet with an orbit so extreme it stretched nearly 1,600 astronomical units from the Sun, over 30 times farther than Pluto's farthest reach. Its elongated, highly tilted path was the kind of anomaly that demanded attention, like a neon sign flashing in the cosmic void. At first glance, it seemed like a potential smoking gun for Planet 9. The hypothesis predicted that a massive planet could fling objects into such eccentric orbits through gravitational nudges over millions of years. Astronomers buzzed with excitement, wondering if this was the missing piece that would tie the theory together. But science is rarely that tidy. A closer analysis revealed that 2017 OF 2001's orbit didn't align with the clustered ETNOS that inspired the Planet 9 hypothesis. It was an outlier, dancing to its own cosmic rhythm, as if it had been shaped by a different force altogether. Instead of strengthening the case, this discovery raised uncomfortable questions. If Planet 9 was responsible for the clustering, why did this massive object follow a different path? Skeptics seized the opportunity, arguing that the clustering might be an illusion caused by biased sky surveys. They pointed out that our observations of the outer solar system are limited, skewed by where and when we point our telescopes. It's like trying to map an ocean by sampling a single cove. Some suggested that 2017 OF 2001's orbit could be explained by billions of years of minor gravitational interactions, galactic tides, or even a long ago stellar flyby that scrambled the outer solar system's architecture. These alternative explanations didn't disprove Planet 9, but they chipped away at its inevitability, suggesting that the outer solar system might be a chaotic tapestry woven by multiple threads, not a single tidy pattern. The discovery of 2017 OF 2001 forced astronomers to grapple with a deeper truth. The outer solar system is a vast, uncharted frontier, and every new find complicates the picture. It's as if each object is a puzzle piece that doesn't quite fit, challenging our assumptions and pushing us to rethink the rules. Some researchers began to wonder if the focus on a single massive planet was too narrow. What if the gravitational effects attributed to Planet 9 were caused by a population of smaller rogue objects? Dwarf planets, not quite massive enough to be planets, but substantial enough to stir the cosmic pot? This idea gained traction as astronomers considered the sheer scale of the outer solar system, a region so vast that it could hide countless undiscovered worlds. 2017 of 2001 didn't solve the Planet 9 mystery, but it added a new layer of intrigue, reminding us that the cosmos is full of surprises. It was a humbling moment, a chance to reflect on how little we know about our own cosmic backyard. And yet it was also a call to keep searching, to keep asking questions, because every anomaly brings us closer to understanding the true nature of our solar system. Behind the equations, simulations, and telescope scans lies a profoundly human story, a tale of curiosity, perseverance, and the relentless drive to uncover the universe's secrets. The search for Planet 9 isn't just about finding a distant world, it's about the people who dedicate their lives to chasing the unknown, often with no guarantee of success. Imagine the late nights in observatories, the endless data analysis, the heated debates at conferences where astronomers argue over statistical probabilities and orbital mechanics. Picture Mike Brown and Konstantin Batygin hunched over their computers, their screens filled with graphs and trajectories, driven by the thrill of discovery. Or consider the amateur astronomers from all walks of life who join projects like Backyard Worlds, Planet 9, combing through telescope data on their laptops, hoping to spot a faint dot that could rewrite history. This is a global endeavor, uniting professionals and enthusiasts in a shared quest to push the boundaries of human knowledge. The emotional stakes are high. For every moment of excitement, say, when a new ETNO is found with an orbit that fits the Planet 9 model, there's a counterpoint of frustration when another survey turns up empty. Science is a roller coaster, and the Planet 9 saga embodies that ride. Astronomers like Samantha Lawler, who challenged the hypothesis, bring a vital perspective, ensuring the theory is rigorously tested. Their skepticism isn't a rejection of the idea, but a commitment to truth, a refusal to accept an answer just because it's compelling. Meanwhile, citizen scientists scientists contribute their own passion, their efforts a testament to the democratizing power of modern astronomy. Platforms like Backyard Worlds allow anyone with a computer to join the hunt, turning a once elite pursuit into a global collaboration. This collective effort underscores a universal truth. The desire to explore, to understand our place in the cosmos, transcends borders and backgrounds. If Planet 9 is real, how did a planet 5 to 10 times Earth's mass end up in such a distant orbit? The outer solar system, beyond Neptune, is a sparse region where the sun's influence wanes, and the primordial disk of dust and gas was too thin to form massive planets. The math is unforgiving. There simply wasn't enough material out there to coalesce into a world of that size. So, where did this ghostly giant come from? One theory paints a vivid picture of the solar system's chaotic youth, a time when planets were like cosmic pinballs bouncing off each other in a gravitational dance. Imagine a young planet 9 forming closer to the sun, perhaps near Jupiter or Saturn, where gas and dust were plentiful. During this turbulent era, a close encounter with a gas giant could have flung it outward, like a slingshot hurling a stone into the void. But instead of escaping into interstellar space, Planet 9 was caught by the sun's gravity, settling into a distant, elongated orbit, a cosmic exile, forever bound but far from home. Simulations breathe life into this scenario. When researchers model the early solar system, they often see planets being ejected into far-flung orbits, with about 1 in 10 simulations producing a Planet 9-like object. These digital reenactments show a chaotic dance of gravitational pushes and pulls, where a planet could be kicked out yet remain tethered to the sun. But there's a more tantalizing possibility, one that reads like science fiction. Planet 9 might not be native to our solar system at all. Picture the sun forming in a dense stellar nursery, surrounded by dozens of young stars, all born from the same cloud of gas and dust. In this crowded cosmic cradle, planets and debris could be swapped like toys in a playground brawl. During a close stellar encounter, our sun might have stolen Planet 9 from another star, pulling it into a tilted eccentric orbit unlike those of the inner planets. Studies suggest a 20% chance of such a capture event in the solar system's first 100 million years, a window when the cosmos was wild and anything was possible. This captured planet would explain the odd tilt and stretch of Planet 9's predicted orbit. It didn't form in the neat, flat plane of our solar system, but arrived as an outsider, forever out of place. These scenarios, ejection or capture, don't break the laws of physics. They align with our understanding of planetary formation and the chaotic dynamics of young star systems. Time, gravity, and a bit of cosmic luck could explain Planet 9's existence. But there's a third possibility, one that blends both ideas. Perhaps a planet formed in our solar system was nudged outward by a gas giant only to be further sculpted by a passing star or a series of smaller interactions over billions of years. The outer solar system is a graveyard of ancient chaos, where the scars of early encounters linger in the orbits of distant objects. Each theory offers a glimpse into a universe where planets can be born, banished, or stolen, reminding us that the cosmos is a place of endless possibility. Yet, without a sighting, these remain stories, compelling, plausible, but unproven. The question lingers, is Planet 9 out there, waiting to tell its tale, or is it a myth we've woven from the threads of our imagination? As the search for Planet 9 stretches on, the scientific community has been forced to confront a sobering reality. What if the answer isn't a single planet? The clustering of ETNO orbits is real, but the cause might be more complex than a lone giant. Enter the alternative theories, each offering a different lens on the mystery. One intriguing idea suggests that the gravitational effects could come from a massive disk of icy debris, a kind of cosmic soup stretching far beyond Neptune. This hypothetical disk, made up of countless small objects, could collectively exert enough gravitational pull to herd the ETNOS into their observed patterns. Imagine a swarm of bees, each too small to matter alone, but together capable of shaping the orbits of distant worlds. Simulations show that such a disk, perhaps 10 to 20 times the mass of Earth, could mimic the effects attributed to Planet 9, offering a simpler explanation that doesn't require an unseen planet. This idea challenges the elegance of a single massive planet, suggesting instead a distributed, almost democratic influence, a chorus of tiny voices creating a gravitational symphony. Yet there's a catch. We haven't observed this disk, and its existence would require a significant amount of unseen material, raising new questions about the solar system's structure and history. Another theory points to the solar system's ancient past, where the echoes of long ago cosmic encounters still resonate. Billions of years ago, when the sun was a young star in a crowded stellar cluster, a close encounter with a neighboring star could have sent ripples through the outer solar system, scrambling the orbits of distant objects. These galactic tides, subtle but persistent, might have aligned the ETNOS over time, creating the illusion of a massive planet's influence. This scenario paints a picture of a dynamic, interconnected cosmos where stars don't just drift in isolation, but engage in gravitational tug-of-war, reshaping each other's systems. It's a slow, relentless process, like waves eroding a cliff over millennia, leaving behind patterns that we now struggle to interpret. A smaller but vocal group of researchers proposes an even bolder idea that our understanding of gravity itself might be incomplete. At the vast distances of the outer solar system, they argue, gravity could behave differently, bending orbits in ways that defy Newtonian or Einsteinian predictions. This modified gravity hypothesis, while controversial, sparks a profound question. What if the anomaly isn't a planet or a disk, but a gap in our fundamental understanding of the universe? Though this idea struggles against the overwhelming success of standard gravitational models, it serves as a reminder that science thrives on challenging the status quo, pushing us to question even the most established truths. Each of these alternatives, disk, stellar flyby, or modified gravity, carries its own weight, but none match the narrative clarity of the Planet 9 hypothesis. They force us to confront the complexity of the cosmos, where a single answer is rarely enough, and every new clue reshapes the puzzle. What do you think is out there? A planet, a disk, or something else entirely? Share your thoughts in the comments, and let's keep the cosmic debate alive. After nearly a decade of chasing shadows, the search for Planet 9 is reaching a critical juncture. Traditional telescopes have scoured the skies, ruling out vast regions where the planet might hide, yet it remains unseen. The challenge is daunting. At 400 to 800 astronomical units, Planet 9 would be incredibly faint, reflecting barely any sunlight, and its slow drift across the sky makes it hard to spot with standard techniques. It's like searching for a needle in a haystack, except the haystack is the size of the universe, and the needle might not even exist. But a new tool is poised to change the game. The Vera Rubin Observatory in Chile, a beacon of hope in the quest for answers. As of September 2025, the Rubin Observatory is gearing up for its legacy survey of space and time, LSST, a 10-year mission to map the entire southern sky with unprecedented depth and precision. Equipped with an 8.4-meter telescope and the world's largest digital camera, Rubin can capture vast sky regions in a single shot, detecting objects as faint as magnitude 24, far dimmer than most previous surveys could manage. Unlike earlier efforts, Rubin is designed to spot slow-moving objects like Planet 9 by repeatedly imaging the same sky regions, tracking subtle changes over time. It's not just looking for a snapshot, it's building a time-lapse of the cosmos, capable of catching the sluggish drift of a distant world. If Planet 9 is within 800 astronomical units and matches the predicted mass range, Rubin should detect it, provided it's not obscured by the Milky Way's dense star field or unexpectedly dim. But even a null result would be significant. If Rubin finds nothing, it could mean Planet 9 is smaller, farther, or entirely different from what we expect, or that it doesn't exist. This makes Rubin the ultimate test, a make-or-break moment for the hypothesis that has captivated astronomers for years. Other efforts continue in parallel, keeping the search alive on multiple fronts. Citizen science projects like Backyard Worlds, Planet 9 engage thousands of volunteers worldwide, their collective eyes scanning telescope data for anomalies that algorithms might miss. Upcoming space telescopes, like the Nancy Grace Roman Space Telescope set to launch in 2027, could refine our models of the outer solar system by mapping its faint inhabitants with unprecedented clarity. There's even the tantalizing possibility that Planet 9 has already been imaged but mislabeled, hidden in old data, or lost in the Milky Way's cluttered starscape. Rubin, however, offers the best shot yet, a systematic, deep survey of the southern sky where Planet 9 is most likely to hide according to the latest models. Its ability to capture faint, slow-moving objects over years of observation could finally bring clarity to the mystery. Whether it finds a planet or rules out vast swaths of possibility, Rubin represents a turning point, a chance to either confirm a new world or lay a decade-long quest to rest. The search for Planet 9 is more than a quest for a new planet. It's a journey into the unknown, a testament to humanity's relentless curiosity and our refusal to accept the cosmos at face value. Each discovery, whether an aligned ETNO, a mysterious infrared dot, or an eccentric dwarf planet like 2017 OF 2001, peels back another layer of the outer solar system's secrets, revealing a universe that is both familiar and profoundly alien. Yet with each step forward, the mystery deepens, like a book whose final chapter keeps rewriting itself. Is Planet 9 a real world, sculpted by the chaos of the early solar system, or captured from a distant star? Or is it a statistical mirage, a pattern we've imposed on the randomness of the cosmos? The Vera Rubin Observatory, with its unprecedented power, may soon provide the answer, but even if it doesn't, the search will have reshaped our understanding of the solar system's outer reaches. This journey is a reminder that science is not a straight line, but a winding path, full of dead ends, surprises, and moments of awe. It's about asking questions without knowing the answers, pursuing truth even when it's elusive, and embracing the possibility that our cosmic backyard is far stranger than we ever imagined. But beyond the science, the search for Planet 9 touches something deeper, a philosophical quest to understand our place in the universe. Imagine standing on a hilltop, gazing at the night sky, knowing that somewhere out there, beyond the reach of our eyes, a hidden world might be orbiting, silent and unseen. It's a humbling thought, one that forces us to confront the vastness of the cosmos and the limits of our knowledge. The outer solar system is a frontier where the rules we take for granted about planets, orbits, and gravity begin to blur, inviting us to rethink what's possible. Whether Planet 9 exists or not, the pursuit of it challenges us to stretch our imaginations, to consider a universe where planets can be exiles, thieves, or ghosts. It reminds us that discovery is not just about finding answers, but about embracing the questions, the uncertainties, and the wonder that drive us forward. As we stand at this cosmic crossroads, waiting for Rubin's verdict, we're reminded that the universe is not a puzzle to be solved, but a mystery to be explored, one that connects us all in our shared quest for knowledge. So, what do you think? Is Planet 9 out there, waiting to be found, or are we chasing a cosmic ghost? Share your thoughts in the comments below, and let's keep exploring the universe together. Don't forget to like and subscribe for more cosmic adventures as we continue to unravel the mysteries of the cosmos, one star at a time.